don't know. Okay, that's the issue. Okay. All right, so the agenda for today is we're going to briefly, I think, touch upon some of the things we said last time and fill in some holes with regard to what it is about the first 6 days that shows us that it's definitely different than the rest of time after Adam Harishon and were created. And then we're going to actually try to explain a little bit about Einstein's theory of relativity and how the authors have made use of the theory of special relativity, which is his 1915 theory, as well as the general theory of relativity, which came a few years later. Did I turn off my phone? My wife is asking me.
Give me the phone. I'll
Turn it off altogether? Okay. All right, she'll turn off the phone. All right. Everybody else should be muted, I think, right, at this time. Okay, so the special theory of relativity and then some contributions from the general theory of relativity, which came a few years later. And we're going to fill in exactly the calculations that show us how the first 6 days of creation can possibly be explained as being somewhere around 15 to 16 billion years. So first, some of the things that we see in the first 6 days in the language of our Chumash, of the Bible, clearly point out that there are things missing. One of the great problems from hundreds of years ago in the conflict between those who believed in a creation and those even in the various different religious orders who didn't see things the way we saw them, was the problem of interpretation. Chazal understood from the very beginning that what took place and what the Torah wrote about in the first 6 days requires interpretation, requires in-depth knowledge, requires lessons taught to us by Moshe Rabbeinu. You cannot read the Bible, our Torah, I don't care which translation you read, right, without recognizing that there's not enough information there, that things are missing, and therefore that you need a source to find out what's missing. And we have a fairly strong notion that it is there because Kadosh Baruch Hu gave it to us and he wouldn't give us something that we couldn't find out something about. So some of these things we touched on, I think, last time, just to review them again. The first things we talked about were the concept of the way in which the Kadosh Baruch Hu described what took place on a particular day. On the first day, it starts off, Bereshis Bara Elokim et Hashemayim v'ha'aretz, and then it tells you a few things that took place. That light came into being, and it was kitov, it was good, right? That came into being. And then we have a year of Ayivok Yom Echad. And then the second day, whatever took place on the second day, The third day, finally, we get to see that a sun is put in place. A sun is created. You can't have days, no matter how you interpret the word day, you can't have it without having the sun. That's how the day comes about. The earth rotating on its axis gives a sunrise and sunset, and the day comes because you have a sun. Without the sun, the concept of day is not there. So when you see you have to know that there's something here that's wrong. Now, some people say what's wrong is it doesn't mean day. It says day, but God didn't mean day. Right? Day means an epoch. We mentioned this last time. Day means some kind of extended period of time during which something took place. Well, there are those that accept that, and even amongst our great scholars and Talmudists, there are those that looked at it this way. There were some books written on the Chumash by excellent Talmidei Chachamim that accept this view. I think in one of the texts, which I haven't seen, but I know it's written by a prominent gadol. The word day is always in quotation marks, right? To tell you that it's not a day. It means an extended period or something. But most of the Gedolim, however, when it comes to these things, side with Rashi and the Ramban. Rashi, and I mentioned that a lot of this material on the first 6 days is in the Gemara Chagiga, starting with Daf Yud Aleph Amud Beis at the bottom and going on for about 5 blot. On Daf Yud Beis and the 12A on the first Amud, right? Where they tell you the things that were created in the first day, and it was more than just light. They tell you 10 things that were created in the first day. In particular, the measurement from one day to the next day, and Rashi at that point says 24 hours. And the Ramban in his writing also says, every day when it says means a day, 24 hours. And the Ramban hints that there are ways of trying to understand how that works. And the Ramban evidently had a tremendous amount of knowledge and understanding of science and what have you, and way ahead of his time. He gives some hints in some of the ways he writes things that there is a message here, that time is not what you think it is. Anyway, that's one problem. The problem of how do you have days when you don't have a sun? Right? That's one problem, right? Then we mentioned the fact that it says that Adam was told not to eat from the Eitz Hadas, not to eat from the tree of knowledge between what's good and what's evil. Right? Because if he does, most you must. Not most you must, meaning you will surely die. Okay, but being human, you tell a person not to do something, that's when he decides it's a good idea to try it. What are you keeping from me, right? Whatever the reason is, Chava and him, they ate from the Eitz Hadas, right? Well, it says you're going to die, most you must, right? An emphasis, not just most you must, right? Well, it took 930 more years before Adam decided to die, before God had decided to execute them. So you can't take literally that it says most you must. Clearly, it doesn't mean most you must. You have to interpret something. Nowhere does it say in the creation of the earth and the heavens, right? Nowhere does it say that the earth is at the center of the whole universal motion, that the sun goes around the earth and the planets go around it. Nowhere does it say that. Yet, many religions, in particular the church and the Catholic religion, what have you, took for granted that we are here living on the earth. It must be the most important thing there is. And therefore, the earth is at the center. They had no evidence for that. There was no way to tell in those days that the earth was at the center. All you can tell is that the sun's going around the earth, but if the sun's going around the earth is also going around the sun the other way. It all depends on what you look at. In other words, without interpretation, not just interpretation that comes to us, right, from generation to generation by the Gedolim. Unlike many, many religions out there, right, Judaism was not a private creation. Kadosh Baruch Hu didn't take Moshe on the side alone and say, Moshe, here it is, I'm giving you the Torah, go out and go teach it to the people. Didn't work that way. Kadosh Baruch Hu gave the Torah to Am Yisrael in front of 3 million people. Men, women, children, 3 million people at Har Sinai. Wasn't done one. If you study a little bit of the history of many of the religions that we have out there, one person had an insight, Kadosh Baruch Hu, he'll say, came to me and I had this vision and I have to do this. And if he's got a good tongue and knows how to speak well and he's convincing, right? He knows how to make miracle water, what have you. Right? He gathers people together, and before you know it, he has a following, has a religion, all based upon the fact that one person said that this is what I have. Most religions are like that. One person. Only our religion said, no, we had 3 million people there, and they taught their children and their children and their children. We have a tradition, going back, right, to Moshe, and never did we have a generation that got skipped without a leader. In every generation, there was a chacham, there was a leader, more than one leader, right, that got the information passed on, tracing it back all the way to Moshe Rabbeinu and others. So there's something special about our interpretation of the Bible. Right? When we say you have to look deep, something special. A few other examples here. Here. This is now, I don't know if I mentioned this last week. One of the Nobel laureates in physics, Professor Weinberg, wrote the famous text, The First 3 Minutes, about what happened after the Big Bang. But he pointed out how statistically unbelievable it is that the earth sustains life and goes on and on the way we do. Pointing out that if the energy that took place at the Big Bang that we discussed last week was different than what it is by 1 part in 10 to the 120th. Now, the number 10 to the 120th, imagine you wrote down a 1, right? And you put after it 120 zeros. That's a huge number. And 1 divided by that is a very, 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 very teeny number. But if the energy of the Big Bang had been different than it was by that amount, life would not have been able to exist on this planet. In simple terms, if we were a little bit closer to the sun than we are, there would be no life. If we were a little bit further away from the sun than we are, there'd be no life. A whole bunch of other things that come together. Now, there are people that believe that life came about because of luck, of statistics. There was whatever there was out there. What do you mean there was? There was nothing out there until there was the Big Bang. But okay, even after the Big Bang, so there is things out there. Right? And then it just accidentally happened that these things came together just the right time, what have you. The temperature decreased enough so that they could form molecules of atoms, molecules of whatever nuclei, but Strefsach, it happens, you can find scientists after scientists that use the head that tell you that statistically speaking, if you had to rely on chance to form one single little proton or what have you, one little thing, if you had to rely on chance, you'd still be waiting. You'd still be waiting after 16 billion years for that event to take place and to create that thing, statistically. That's how impossible it is that you should rely upon luck or statistics to have formed what we have here in the universe. According to the authors that I looked at, I'm not a paleontologist or a cosmologist, and that I know what's going on all over the place. I hardly read any books on that. But it seems to be clear to them that you can't find any reputable scientists that will still tell you that there wasn't a creation. Now, remember, having a creation doesn't mean there has to be a creator. Having a beginning doesn't mean there has to be a beginner. But at least they are now recognizing that this was not a steady state universe that was there all along, as Aristotle had predicted, and that many, many people believed in as late as 1940 something, and people were still saying that this was a steady state. Einstein made a terrible mistake going back when he put together the theory of relativity, special relativity, because he was working and he said, now going back, this is now 1917, when he was working on the theory of special relativity, and it dawned on him from what he was doing and from what some knowledge of looking at the distant planets and stars and what have you, that the universe was not a constant. In other words, that it was expanding. And he didn't believe that that was possible. In his mind, he said, well, it can't be. It has to be that it's now in a steady state, consistent, what have you. So he fudged one of his formulas. He threw in an extra constant to one of his formulas so that the formula shouldn't look like it's an expanding universe, but that and it still had his equations, but it was a little bit different than it should have been. Only in later years did he realize that he made a goof. And had he at that time followed what he was seeing, followed the equations he was generating, followed his mind, where it was taking him, that he would have been the one to discover that there was a Big Bang and there had to be a creation in the beginning, instead of having to wait until 1965 when Penzias and others proved by measuring the so-called background radiation that still exists from the original first bang, Great Bang, right? Measured the wavelength of that, which cemented the fact that we had a beginning and an end. Just a couple of more examples of this, which I find amazing. One of the things that you have to appreciate and accept in a world that had a creation by a creator, like we believe, namely that Kadosh Baruch Hu preceded the world, right? He's outside the world. Right? But one of the things that you have to examine and understand is some of the strange things that Kadosh Baruch Hu lets happen in this world. Example, To aid in the conquest of Canaan, Kadosh Baruch Hu promises to send hornets in order to make the enemy flee. So here's God controlling nature. Just 2 verses later, this is in Devarim 7:22. And the Lord thy God will cast out those nations little by little. Why little by little? Lest the beasts of the field increase upon you. The animals there will bother you. So notice the problem, he says here. If God can control the hornets to drive out the nations, why doesn't he also keep the beasts from multiplying and harming Israel? In other words, at certain levels, Kadosh Baruch Hu lets nature take its course. Example 2. Of the 12 tribes of Jacob, only the tribe of Levi was to serve directly in the temple in the Beis Hamikdash. For this, they must be physically fit. The Chumash provides a list of birth defects which disqualify a Levi from fulfilling this potential. Why have birth defects? The biblical concept of an infinite Kadosh Baruch Hu is a God that could make all births perfect. The author says, if I was God, I would like to have done something like that, make them all perfect. But the world that's described in the Chumash does not function according to our demands. Most children are born healthy and physically normal, but not all. Nature has its level of freedom. Kadosh Baruch Hu withdraws himself and allows nature to proceed. And when nature makes mistakes, when the natural way doesn't seem to work out well, right, he retunes. Dor HaMabul, right, was not doing well. Kadosh Baruch Hu was unhappy, right? So he brought a flood. We'll start over. He told Noah, we're going to start over, right? Take you, whatever are 7 people, 8 people, we're going to start over again. Retune. And there were other times when Kadosh Baruch Hu said, all right, we have to step back and retune. Maybe when the Chumash uses the word that it sounds like Kadosh Baruch Hu changed his mind. Kadosh Baruch Hu doesn't change his mind. Got the word that he used, Vayinochem, Kadosh Baruch Hu had regretted or something like that he did. Not regret. The regret is that his people did not do what would have been nice for them to do. And as a result, he has to come in and he has to retune, get started again. Third example, Kadosh Baruch Hu saw the light on the first day, right? 4th pasuk in the Torah, that it's good. And God saw that the ocean and the earth is good. That's in the 10th pasuk. And God saw that it, the origin of plant life, right, is also good in the 12th pasuk, and on and on. God sees that it is good 7 times in the 31 psukim of the first chapter in Bereshis, the creation chapter. 7 times it is good. Almost a quarter of all those verses, right? They have 31 verses and 7 times 4 is 28, almost a quarter of it, right, are devoted to God's discovering that it's good. Didn't God realize from the start that it would be good? Maybe, probably, but it doesn't say that explicitly in the text. These are just examples to show you why you cannot take what's in the Chumash literally. We understood that. Kadosh Baruch Hu told us to Moshe Rabbeinu. Moshe taught it to us. Right? You can't take it literally. The Gemara I mentioned in Chagiga, the Mishnah says, Ein Darshan Berayis B'Shlosha, V'lo B'Maaseh Bereshis B'Shnayim. You're not supposed to sit and teach Maaseh Bereshis, right, to 2 people. Reason, whatever, because one of them will ask a question, and while you're talking to the one explaining what the question is, the other one will drift off and think of other things, but the bottom line is you have to have students that you have faith in terms of their emunah, because there are strange things that you're going to learn when you learn Ma'aseh Bereishis. I sometimes used to think that that's why in many yeshivas they start teaching Chumash not in Bereishis. Where did they start from? Vayikra. Vayikra. Start teaching the kids Kabbanos. You teach Kabbanos, whatever you tell the kid, he doesn't really know that there's something you have to ask, that something that's not seem to be right. But if you teach him Bereishis, you teach him some of the things, like you said now, most kids understand that if you don't have a son, you can't have a day. Because they learned that next door when they took English in kindergarten. The kindergarten teacher had a globe and used to spin it around, used to point at it. Is that what they know already? So right away, you're going to have questions being asked, but what are you talking about? They start talking, right? Once they start talking, they'll have doubts. So a lot of yeshiva says, wait till you grow up. When you're 40 or 50 years old, then you sit down, you study Ma'aseh Bereishis, and maybe then it'll make a lot more sense than it is now. At any rate, we have to recognize that Kadosh Baruch Hu, concept of Tzimtzum, whatever, Kadosh Baruch Hu has to sometimes withdraw himself, right, and let the world travel on its own, in its own nature. The Ramban says this almost word for word, right? That you have to go. Right? Kadosh Baruch Hu brought the world. Everything you need to exist on the first day is there. It's all in, right? Just had to be put into place, or what have you. And now it's up to you to do what I told you to do, right? One of the most difficult things I thought to contemplate and understand, right, which sets aside the first 6 days from everything else, is the fact that our calendar is based upon the 6th day forward, right? The first 6 days don't exist in our calendar. Our calendar starts from the day that Odom and Chava came into being, from the 6th day, right? That's our Rosh Hashanah. But the fact that the world was created on the 25th day of Elul, that's not in our calendar specifically as this time. Right? So some say the reason for that is because the most important thing in creation was to produce humanoids, and Adam and Eve, right? To start to the human colonies, right? To have people on the earth, people who will recognize Kadosh Baruch Hu, right? And live by his rules. So that's why. But 6 days don't make that much of a difference. I mean, I could have started the calendar on day one and wouldn't be so terrible. So, yeah. But we don't. Again, one of the reasons possibly that we don't is to make you notice that there's something different about the first 6 days. Already said last time, that when you see what happened in the first 6 days, it tells you there was this, and the day was over. It doesn't tell you that at 3 o'clock there was this, and at 5 o'clock there was this. Obviously, there were things that took place, it took time. It doesn't tell you that. Just tell you this, and then the day is over. That changes. Later on, when there are humanoids around, you get more in-depth explanation of what's going on. So-and-so was born to so-and-so, right? Had a first child after when he was 103 years old, and then he married again, and he had more children. Yeah, you have some depth about what's taking place at particular times. It's a whole different view of time. And that's when the time is what we call land-based. That's when you're at the time that we have now. From the day that Odom and Chava came into being, right? We have 5,788, whatever, where we are now, right? The years. Before that, we had close to 15.5 billion years. How you get that in those days, I said, we're going to try and give you some idea of how that happens. I think I said, and it's not a secret, that the basic piece of information that allows us to squeeze 15.5 billion years into 6 days is the Einstein theory of special relativity. Just an overall view, word, and then we'll do a little more in depth, but I promise not to be overly mathematical. I'll ask you to take my word for a couple of things so we don't have to go through all the mathematics. The theory of special relativity that Einstein published in 1915 basically says the speed of light is a constant for everybody, no matter where you are. When you measure the speed of light in a vacuum, the answer you're going to get is 3 × 10⁸ meters per second, or in our familiar units, 186,000 feet per second. Let me calculate that. I told you it takes 8 minutes for the light from the sun to get to the earth. So that if you go outside and you say to somebody, see, there's the sun, you could be lying. The sun could have disappeared 4 minutes ago, but you won't know that for another 4 minutes, because the light you are seeing now is light that was sent out 8 minutes ago. Likewise, all the stars you see at night, many of them may not be there anymore. Some of them are millions of miles away. The light you're seeing was sent out maybe on the second day of Bereshit, right? And it's starting to reach you now. Right? But that star may have blown up already. It may have become a nova and then a supernova and may have blown up and may not be there anymore. But you won't know it for another million years. Right? Your great child, well, maybe they'll see it. They'll see a nova, they'll see a brother. So again, so the speed of light is a constant in vacuum. And that's very important to understand. Even if you're moving and you measure the speed of light, it's going to be the same constant. It doesn't change. You can't increase the speed of light by taking a flashlight and running with it. So the light leaving the flashlight is at 3 × 10⁸ meters per second, but the flashlight is moving at 5 meters per second. So maybe now the speed of light is greater by 5 meters. No. Even if you're moving, the speed of light that you measure will always come out to be 3 × 10. This is a marvelous thing. When you realize all the different things that light is, you realize how special it is and why it deserved to be the first thing to be created. What you don't understand, what I don't understand sometimes, is why the first pasuk says that Kadosh Baruch Hu created Shemayim v'Oretz. Why didn't it just start right away with light? That would have made it clear that the Big Bang was the first thing with this ball of fire and energy. There are reasons for that too, but first days. Second, and here's the big one for us. The theory of special relativity says that time is not the same for all people and all individuals where they are. If you are moving and somebody else is standing still, you do something in your moving system, which I'll explain with you in a moment. you take, for example, like everybody did this as a kid. You're in the train, right? And you have a ball in your hand, and you throw the ball up, and you catch the ball here. You throw it up, it comes back on your hand. Throw it up, comes back on your hand. Now that happens exactly the same as if you're standing still. Because when you're moving, the ball is moving with you. The ball is also moving. If the train is moving, let's say, 10 miles an hour. So your hand is moving at 10 miles an hour, your face, everybody, you're all moving at 10 miles per hour. So is the ball. The ball is moving this way towards you at 10 miles per hour. And so am I. So when I throw the ball up, we're both moving the same way. It comes right back into my hand. It doesn't fall behind me, as you might think. You throw the ball up and then you escape and you fall. No, because the ball is moving forward also. But that doesn't happen with light. Light keeps the same speed. So what we're going to say is the following. I'm going to show you a little picture. Tell me if you can see the picture. Yes? Can you see that picture? Can I make this picture any larger? No? If I went to share, would it be bigger?
I don't think so. I don't know what to do with share. You'll go and you'll
No, I think it didn't do anything. All right. Maybe if I point out what's here. Here, in the top picture over here, we have somebody in a moving vehicle, a train or what have you. He's holding a ball in his hand. If he flips the ball up and hits the roof of the train, or not quite hit it, but almost hits it, and it comes back down into his hand. The same would be true if the train is standing still, go up, and come back into his hand. On the other hand, to an observer who is standing on the platform as the train goes by, that observer doesn't see the ball go up and down. That observer sees the ball go in an angle, like so. Because the ball is moving sideways, the train is moving, right? So when you throw it, it goes up here. When it comes back, it's going to come back over here. In other words, in the time it takes for the ball to get to the top and to get down, the person has moved forward, moved over here, yet the ball comes back into his hand. But it couldn't come back by going straight up and down, because if it went straight up and down, it would be behind him.
Oh.
It had to travel this way. And that's what the person standing on the platform sees. He sees the ball go up and then come back down an angle. Now I want you to think of this now as not a ball, but as a flashlight and a beam of light. So a beam of light here goes up and right back down. And over here, the light would go up, hit the thing, and come back over here. Well, I'm sure you know and realize that this line, right, is greater in length than the one straight up and down. It's like the hypotenuse of a right triangle is bigger than the side. So the distance traveled by the light to go here and here is greater than the distance of the light going straight up and coming down. Therefore, when the person inside the train says, oh, the ball came back right down to me in 5 seconds, if he communicates that to the person who's standing outside, the person outside says, uh-oh, baby, something's wrong with your watch. Because it had to take more than 5 seconds because it traveled a greater distance and the speed of light has a constant value. It had to be bigger. Couldn't be the same time. But no, but I got 5 seconds. I didn't get to 7 seconds. You didn't get 7 seconds because your clock is running slow. In other words, in a moving system, time slows down. Now, in 1915, when Einstein published this, what have you, it was considered a theory because nobody really completely appreciated it or understood it, what have you. But in the last 106 years, this has been tested over and over again in various different ways, and nobody says that it's a theory anymore. Relativity is law. That's nature. Nobody disagrees with relativity. the addition that comes from general relativity, which we don't really need to explain this my separation, but it's of interest anyway, is that not only does time get slowed down by motion, but time is also slowed down by where you are in a field of gravity. Let me explain. Most people already heard and understand that you won't weigh the same thing on the moon as you weigh on Earth. On Earth,
Of course not. There's the gravity.
80 pounds. A person took his scale, went to the moon, and weighed himself on the moon, he would weigh less than that. How much less? About 1/6 less. You would have lost a quick 30 pounds or something like that by going to the moon. Right? Because gravity, right, on the moon is less than it is here. A person's weight is determined by his mass, which never changes no matter where you are and how fast it changes when you're moving. But if you're stationary, wherever you are, it's the same mass. Mass times the acceleration of gravity on your location determines your weight. On the Earth, the acceleration of gravity is roughly 10 meters per second, 32 feet per second squared, or 9.8 meters per second. That's the acceleration of gravity. So if you have a mass of 100 kilograms, that would be at 250 pounds or something like that. Right? 100 kilograms, your weight would be 100 kilograms times 9.8 meters per second, right? So it'd be 980 newtons, which is the unit of weight in the metric system. But if you went to the moon, the acceleration of gravity on the moon is only 1/6 of what it is here. Here it's 9.8, on the moon it's 1/6 of that, which is 6 into the 10, whatever, right? Therefore, your weight would be 1/6 of what it is here, because your weight depends on the acceleration of gravity at your particular location, right? And your mass. And your mass, when you're still, doesn't change. That's what one of the great things that general relativity added to the mix, besides a few other things. But anyway, it's the other thing that concerns us, the fact that with motion, right, time slows down. Putting that into the discussion of the 6 days, the primeval explosion, the ball of fire that happened at time 0 was extremely hot. So hot that things, even if there were charges there and particles, they couldn't combine. They just wouldn't stay together. It didn't take long to cool down, though. As I said, Weinberg's book, the first 3 minutes, by the time the first 3 minutes were over, we were practically in a normalized situation, although it still took another five days and change to get to where we are. But it turns out that the speed was so enormous that the clock turns down. Now, what clock are we talking about? Here's who's measuring this? What are we measuring? How are we measuring it? When you take a measurement, you have to have what we call a coordinate system. You have to know where the X direction, Y direction, Z direction, and where the time is, what time he was. It turns out that for the purposes of measuring the age of the universe, the primary thing, the mass that was created, has to be your reference point. And if you use that as a reference point, you can measure what the the amount of time passes. In other words, taking into effect the expansion of the universe, how far away planets are, and trying to imagine that everything got shrunk back into a point someplace. So you can get an idea and a fix of how many years we have. So I have a chart which I'll try to share with you again. On the day by day, oh, you're not going to get to see this. There's a chart here. I'll read a couple of things to you, right, on this thing. This is the duration of the first 6 days. Right? Day one, now remember, according to what we're going now, we're treating every day as 24 hours. So the first 24 hours, from the Earth's perspective, looking backwards in time, the length of that first day would turn out to be 8 billion years. The approximate years before Adam at the start of each day, right? So at the start of the first day, the approximate number of years before Adam is going to come on stage on the 6th day would be 15.75 billion years. The second 24 hours, now things have slowed up a little bit, so the amount of time that we have that changes is smaller. So the second day was only 4 billion years long. Right? And by the time that day is over, we're 7.75 billion years back before Adam. The next day, the third day, it's down to 2 billion years. From Earth's perspective, it's 2 billion years. And approximate years before Adam would be at the start of the day was 3.75 billion years. The fourth day was 1 billion years in length and is 1.75 billion years before Adam. The fifth day be 500 million years and is only 3/4 billion years before Adam. The last day is 250 million years, and it's 250 million years before Adam. And near the end of the day 6, we are where we are now. That is to say, the time before us now, on the 6th day, would be like 6,000 years, 5,788. And so-called relativistic effects are no longer here. Things are not moving fast enough for that to take place anymore. And we're all in what we consider to be normal time zone, if you will. Again, you are not forced to believe that there was a creator. But it's hard to not accept the fact that there was a creation. Right? Scientific evidence all point to the fact that there was a Big Bang, and before that, there was nothing. Before that, there's no time. Without a material substance in the world, time is meaningless. You can't speak of what went on, how long did it last, or before, no, you can't. Because there's, you only have a time, you have a material something that exists. So it's possible still to be, a non-believer, but I think it's of interest to hear what some of the comments were by people who were very knowledgeable. Yeah, in many cases. Professor of mathematics and astronomy at Queen Mary University in London, Bernard Carr. He says, if you don't want God, you better have a multiverse. In other words, if you don't want God, you have to believe somehow that the first bang created many universes, right? Like imagine an ocean in which you have bubbles all over the place. Each bubble is like a separate universe, a separate something. And I'm not sure what you gain from that. The logical conclusion derives from the reality that there are many physical constants that must work seamlessly together. In order to have the existence like we have, a lot of things have to fit into place, as we mentioned earlier. Changing any one of them or all of them could preclude the possibility of complex life.
Okay.
But could we really have all those matched physical constants by lucky chance on one roll of the cosmic dice? Remember, I told you that Einstein once said that God doesn't play dice with the universe. He didn't believe it. That's because he was anti-quantum mechanics. He didn't realize it, that he put quantum mechanics on the map. When he explained the photoelectric effect, he introduced the concept of quanta. The light has a certain quantum, for a different time. According to the most widely read journal, Scientific American, this would be statistically just about impossible on one roll of the cosmic dice, since the properties of atomic and subatomic particles conducive to forming life are so specific. Some examples of the luck you would need here. The electric charge of the proton, that's the particle that's at the center of the atom in the nucleus. That give the atom and hence give matter much of its mass. The proton gives much of mass to matter, as does the neutron. But the electric charge of the proton must be exactly equal and opposite to the electric charge of the electron, which swirls around on the outside. Even though the proton has a mass of 1,837 times that of the electron. It is the sharing of these ultralight electrons among atoms that allows molecules to form. No molecules, no life. That's one thing that you have to. The force that holds atoms together, the strong nuclear force, is balanced on a knife edge for allowing hydrogen atoms to be superabundant in the universe. If there are no hydrogen atoms, there's no stars. Stars make their shining light and energy by fusing hydrogen, the lightest of all elements, into helium, the second lightest of all elements. In that fusion, energy is released. This is the energy of the sunlight that we see. That's how the stars make their light. If this did not occur, there would be no heavier elements like carbon and oxygen. No heavier elements means no life. As with all elements heavier than hydrogen, carbon, the one element able to form the complex chains required for life, is built from lighter elements within the cores of stars. But the process involves a complex, exquisitely tuned series of reactions. Not something that's going to happen. Somebody turn that off, or how about that? Thank you.
Okay, fine.
Most incredulously, carbon is the most abundant element in our universe that is solid in the temperature range that water is liquid. And you have to have both carbon and water to proceed beyond to other elements or what have you, and to sustain life. And it's just accidental that carbon is a solid, right, at the temperature that water is a liquid, so that these things can take place. Just a minute to read something interesting. The Bible claims that there is a marker in history that indicates God's active involvement in history. That marker, according to the explicit statement in the Bible, is the Jewish nation. The Bible claims that the Jewish nation will always stand out for better or for worse, but always be abnormally evident in the flow of history. The word holy in Hebrew, kadosh, does not mean better or wonderful. It means separate or apart. This is an exact parallel to the word Hebrew, which means from the other side, right? Ivri, ova, from the other side, separate. God has used the Jewish people as a marker of God's presence to make this presence known among the nations. The fact that the Jewish people have survived and even thrived in the face of exile, dispersion, and enduring anti-Semitism testifies to this. Now, a very well-known author wrote the following. What is the Jew? What kind of unique creature is this whom all the rulers of all the nations of the world have disgraced and crushed and expelled and destroyed and persecuted, burned and drowned, and who, despite their anger and their fury, continues to live and to flourish? What is this Jew whom they have never succeeded in enticing with all the enticements in the world, whose oppressors and persecutors only suggested that he deny and disown his religion and cast aside the faithfulness of his ancestors? The Jew is the symbol of eternity. He is the one who for so long had guarded the prophetic message and transmitted it to all mankind. A person such as this can never disappear. The Jew is eternal. He is the embodiment of eternity. That was printed in a journal called The Jewish World in 1908. The author of that wrote some very famous books. His name was Leo Tolstoy, who wrote Anna Karenina and War and Peace. After discussing nuances of nuclear physics with Nobel laureate physicist Leon Lederman, it was brought up the subject of spirituality. He said it was spooky, this is Leo Lederman, spooky that after 2,000 years of exile, the people of Israel has returned to the land of Israel. Spooky meaning abnormal. Yet the Bible over 3,000 years ago predicted that the Jewish nation would stand out and be different. In the act of creation, science has discovered God, who is active in the history of the creation that it brought into being. As the Rambam wrote, study nature if you want to comprehend the nature of God. Anyway, I hope that some of this that we said makes some sense, and at least you can say that you heard somewhere that with the law of special relativity, you can explain the expansion of time that happened during the first 6 days. And of course, by the end of the 6th day, we were on regular Earth time. But before that time, we were on time that you measure if you were traveling along with that primary explosion particle or any part of it. Incidentally, the reason why the first thing that one of the things created was to take Choshek, remove the Choshek from Or, from the light, because in the primeval explosion, there were charged particles, but they weren't connected into molecules or atoms, things like that. They were plasma. And around the plasma, you have like a sheath. That is, it couldn't get out. There was no way for the light to escape. So it appears dark. Then when it cools down, and then you start forming atoms, molecules, or what have you, then it becomes more transparent. So it's like light coming out of the dark. That's the concept. I had a lecture many, many years ago in Muncie, in our shul. There was a physicist that I wish I could remember, I don't remember his name, but he came and he spoke about the first couple of days in this particular light, and he pointed out how you could see the concept of black holes in the Psukim, in Bereshis, the concept of black holes, right? Which doesn't allow light to escape, right? and therefore, essentially black. And if the temperature cools down or what have you, it's possible eventually that it changes and you get something out. Anyway, it was an interesting thing. So there were all kinds of wonderful things that are related to our understanding of the scientific world, right, that are there. But you have to look for them and you have to know how to find them, but they're there. And it's not made up stuff, it's stuff that's there. Again, one of the psukim that the authors alluded to is the famous passage that says that Elef Shonim, 1,000 years, right, could be like a very, very short time. As one of the psukim in Tillim, in chapter Tzaddik 90, right? Elef Shonim Yom Espo, right? 1,000 years, like yesterday, like one day, or even like just a piece of the nighttime of the Shmur in the lifetime, in the evening. So we have our. Okay, I'm sorry that our time is up. We are scheduled, as I say, for another class next week. I'm not sure if we will proceed or what. How many of you want to continue these classes?
I do.
Show of hands. Can I just have a show of hands because I can see you?